Yep. Hi there. I'm going to present some work we did 2 years ago where I work. So this is the outline. I'm going to explain you who I am, why we've been doing these kind of things we do now, some key concepts to understand the research or the results. Then we'll focus on the city influence. City influence is when you visit the city, which kind of influence makes that visiting that city to our future journeys. Okay. Then we'll compare local and non-local behavior. Is it true that we visit different things in cities depending on our residence? Then we'll focus on city attractiveness. Are there cities that are more prone to be visited by people from, I don't know, European countries, from America, Asia? We'll try to cluster the cities depending on the touristic attractiveness, and then we'll see if we can cluster the world, the cities of study in different clusters depending on different things, and finally we'll see some data and touristic sites. So who am I? Study mathematics, but I've never been working as a mathematician. I've been working as a computer scientist. I started working on a video game design company, doing animation systems. So as you see, I've been doing things, different things. Then I moved to a company where we were developing software, Greek middleware, distributed, and now I work on a research institute in Mallorca with physicists. So I'm a computer technician, so I have to deal with different perspectives of things. And even I'm a computer technician, my work is also related to human mobility. I'm also in a group of socio-technical systems studies. So go for it. Tourism. That's where I live. But my house is not here, but I live in Mallorca. You know, tourism is important. In our island, tourism is very, very important. And in some cases, people from Mallorca come to Cáceres. This is El Salto del Gitano, I think. I've been told that. And it's here. Some of you know that people from Mallorca coming to Cáceres, it's not easy. We haven't slept very much last 2 nights because we had some problems. But people usually travel. We travel a lot. We, society, we've been traveling the last years. We moved in a different way. We did it 10, 15 years ago. So we can start studying that kind of tourism. Why now? Because we have the knowledge. We've had the knowledge for a long time. Now we have data that 20 years ago we didn't have. Even we had data, we didn't have access to that kind of data, so it wasn't easy to do that kind of things. But most importantly, we have tools. For those things, we are using Python ecosystem plus R. He's not, but should be. We analyze data, so we usually use pandas. Our editor is Jupyter. You know, we use usual things, and we plot it with MATLAB, Bokeh, GeoViews, HoloViews, depending on what we do. But here we focus on maps. Don't worry, not a lot of code and no code to upload anything. So our data set. What kind of data set do we have? We work on Twitter data, and for this study we had 1,000 days of geolocated tweets. You know, Twitter has a public API, so we downloaded we are receiving the streaming of Twitter. We had some tweets, and for this we got all the geolocated tweets in the world. Then we had to clean them. Yeah, that's the worst part of working with data. We didn't clean it. We didn't have to do a lot of things here. We just removed the users that were traveling too fast. I mean, faster than a plane. We suppose they weren't humans. Don't know. Maybe time travel and space travel is there. And we removed the users that hadn't got enough tweets. So we didn't have a very large data set, but enough. I think all you know what a Twitter looks like. This is one of them with fake data, fake IDs. I'm gonna skip there. Here there were 2 videos to see how humans spread it after visiting Madrid or after visiting Mallorca, and the patterns are quite different. In people that visit Madrid go to South America, but people that visit Mallorca, for example, go to Germany, Great Britain, Japan, and different distribution. We did the same thing for other cities, and for example, Moscow had a very, very different pattern from other European or not that far away cities. Some concepts. I'm gonna go through them very quickly. You see in a plane, in the plane, measuring the distance is quite easy. Measuring the distance on a 3D surface is not that easy. We have different measures. In that case, we are using gray circle distance. Very easy to do it because we have a package, and you just put the 2 points you want to get the distance from and to, and you call gray circle method. Important, if you are using one kind of distance, stick to that one, don't change, because the results are going to be nice. We have to we have to know where people live, so we have to discretize the space. We made a grill of 100 kilometer square cells using a cylindrical projection. We didn't have a lot of inhabited cells. There's a lot of sea in the world, but we thought there would be more. So we defined the place of residence as the place where 1/3 of the tweets of the user lie in. Okay, with that definition, that it's not really strict. It's fine for 95% of the users we were studying. This is the distribution of places of residence of people who visited La Alhambra in that period of time where we are getting care. There's some code here to get the place of residence, but I'm gonna skip it because we don't have a lot of time. You'll have the information there, and we'll go to city influence. To define the city influence, we get users' tweets, all the tweets the user post after visiting a city. So we had some places, and we get the average radius of that user. Okay. Then we do the same for all the users that visited the city. So we have an average on average. But we have a problem because we have isolated cities. So in cities in Europe, we have a small radius, and cities in Oceania and in South America, for example, have bigger radius. So we normalize, the average of the average. I don't know how many averages, and we just normalize with the isolation, depending on the distance of the city to the place of residence of the users that tweet there. Another measure we have is the coverage. Do you remember the strategization we did? So we just take into account the number of cells that user visited after tweeting in a city. We make a ranking, and we have something different. Usual rankings have New York on the top. It's always New York there. New York is not here. Well, we were studying 58 cities in the world, very populated, because Twitter, we have small number of users, we can have problems, and we don't want to have bias issues. So it seems consistent. We have Rome, Paris, and Lisbon. In fact, for that things, we didn't use all the users that were tweeting for a city, because we had a different number of users in the cities. So we measured that just randomly extracting 300 of that users. The data was consistent, so we stick to that. Different ranking. What about local and non-locals? Do we behave differently? Do locals stay quiet and go residence to home, residence to work to residence to buy things? And do visitor really move a lot? We had to define we had to decide if a visitor if a Twitter user was a local or non-local, depending on the place he tweeted. If the average of his tweets or her tweets were in the city, we decided that it was a local user. And the trick is that we define city as a circle. I'm a mathematician, Circle is the easiest thing. So city center was the town hall and 50 kilometers radius. Some calculus, and here we have locals and non-locals behavior, number of cells they cover, and the average, the normalized average radius. It seems we behave differently. Every dot, triangle or square, it belongs to users in a city. So you see, locals tend to move very, very calmly and don't visit a lot of places, as we thought, and non-locals move around. Different rankings. Lisbon and Paris are still there for visitors, and Rome, that was the third one, he is the fourth, consistent. But when visiting a city, where do we come from? We did the same. We already had the grid and defined the coverage, so repeating the same thing. We counted. You basically, at the end, you always count things. The number of cells or countries he visited after visiting the city. No, that's wrong. There should be before visiting the city. And consistent. City attractiveness. People from Rome, Paris, and Lisbon, that were the top three before, are the cities, the three cities are the ones that receive people from different countries. Okay? More different countries and more different cells. Then we try to cluster the world in a different way. We had a graph the weights depended on the connections. If you visited one city and the other one, that weight depended on that. And Mexico and Japan appeared as independent clusters. And the cities in Australia were related to Asia. So if you visited Australia, you were it was more easy that you could visit Asia, and on the other way around, if you were visiting Asia, it was easier to go to Australia. That was done in two different clustering methods, so consistent. We didn't expect to have that. Here, New York was the top one. Why? Because everybody wants to visit New York. Okay. But remember that in the other ones, it was not there. Bonus track, the touristic sites. We did something similar on 20 touristic sites. Which ones? We tried getting one single ranking and get the top 20. We found that every ranking had a different top 20. We get our top 20 different places, and we did something similar. But here I'm going to show you the distribution of the countries of residence, the people that visited touristic site. In this place, in this slide, you see that Taj Mahal is the touristic site of the 21 we selected that had the most plain distribution on the place of residence of the visitors. I mean, here there were people from a lot of countries that were visiting Taj Mahal. But if we did the same for Grand Canyon or Times Square in the States, we had the opposite. Most of the people who visited places in the States were from the States. I mean, we know the States is a very big country, but we didn't know if that was enough to have that differences. I mean, he is very, very, very distributed, and the other one was basically focused on the States. Ranking. Taj Mahal, Giza, depending on the radius, we did the same. Radius, coverage, cells, the place of residence of cells, and countries of the residence. And you see they are not different. In this study, we didn't really measure, we hadn't started comparing with other results. We got that, and we are working on it. Discussion. Final slide. Here we presented a work that's not that presents a different approach from the usual. It's not the traditional approach. In fact, it's, as I mentioned before, it's not related to the number of visitors, and we think that when removing that, the rankings were quite different. So maybe people on geography or sociology can try studying different measures. We know we have underrepresented population, we have bias, but on the other hand, we have some results that reliable results that say that when dealing with cities, we have no problems with bias, and there's enough population to have that information and to work with Twitter without problems. We can measure competition and interaction between cities with Twitter, and we've seen that our approach was consistent because all the results were the same. So thank you very much. And if you have any questions.
Yes. So, if you have any questions, please say it out loud. Antònia, thank you very much. She will repeat it, please.
Yeah.
So the streaming will get it. So.
At the beginning of your talk, I was wondering, I was thinking about the business trips, and in the business trips could distort your results. But, for example, I was thinking of London or...
Being a hub.
But I guess the difference is that people in a business trip don't bother to do it boring stuff, or could that be the reason why Frankfurt or London are not in the top?
Yeah, I mean, repeating the question, he's asking if business trip can be important for that kind of results, and if they affect the results as not being London in the top 10. I mean, yes, it can, and we are trying to separate local and visitors, but pleasure or leisure travels and business travels. We are still working on that. We just don't know if it's going to be, but we suspect that it's that, because when you are traveling, you are not tweeting, I'm here, I'm there, I'm visiting that. You're saying, yeah, if you tweet, you say, I'm a meeting, I'm getting sleep.
Yeah.
Thank you for your talk. One question, maybe I missed it, but what was the main motivation of the study?
What is that? Sorry?
What's the main motivation?
When the main motivation? I work in a research institute, so motivation can be. He's asking the motivation of the study, motivation. I mean, we are studying sociology and human mobility, and we've been working on Twitter data for a long time, and we were trying to know if Twitter was good enough to decide and to replace all kind of data. So census, and with travels you just have information on the companies, and you have to pay for that information to know the scales and the movements of the people. So we were trying to get the free data source to keep on working on that.